Why did they do that?
But
Why did they put it so late this year?
I don't know for sure. It must be have something to do with the panic. We'll start in 1 minute. Today we'll be in section 7.2 and 7.4. So ultimately we want to learn how to solve equations with rational expressions. So just like fractions, rational expressions must have common denominators before they can be added or subtracted. So we'll practice a few additions and subtractions involving fractions and rational expressions. So if they have different denominators before we can add or subtract, we have to have a common denominator. So these two denominators, 30 and 45, well, we need to find a least common denominator. And we can find a least common denominator if we use the factorizations of 30 and 45. The prime factorization of 30 is 2 times 3 times 5. 2 times 15 is 30. The prime factorization of 45 is 3 times 3 times 5. So the least common multiple has to have the factors that appear in both. So the least common denominator has to have a factor of 2. The least common denominator has to have 2 factors of 3. and it has to have one factor of 5. So when we multiply these together, we get 90. Okay, so what we do is we multiply each of those factors by 1. So this one, we're starting out with a denominator of 30, but we need a denominator of 90. So if we multiply this factor by 1 in the form 3 over 3, then 30 times 3 is 90. For the other fraction, 11 over 45, we're going to multiply by 1 so that we end up with a denominator of 90. So this time we'll multiply by 1 in the form 2 over 2. Okay, then we do the arithmetic. 17 over 30 times 3 over 3. In the numerator, 17 times 3 is 51. In the denominator, 30 times 3 is 90. For the other product, 11 over 45 times 2 over 2. In the numerator, 11 times 2 is 22. In the denominator, 45 times 2 is 90. And now that we have a common denominator, we can add the fractions. So 51 plus 22 over 90, or 73 over 90. Hey, we do the same sort of thing with expressions involving rational expressions. So before we can add these two rational expressions, we have to have a common denominator. So sometimes when you have denominators like this, it's not too hard to find the least common denominator. One denominator has a factor of 3, the other denominator has a factor of 2. So a multiple of both is 6. This denominator has x to the second. This denominator has x. So a multiple of both is x to the second. And then this denominator has a factor of y, and this one has y to the second. So the least common denominator has to have y to the second. Okay, so in the next step, we'll multiply each of those factors by 1 in a special form so that we get a common denominator. Okay, so this denominator starts out at 3x squared y, and we want to end up with 6x squared y squared. So I would need to multiply this by 2y. So that means the form that 1 takes is 2y divided by 2y. And then you can check. 3x squared y times 2y is 6x squared y squared. And then for the other one, we're starting out with a denominator 2xy to the second, and we want to end up with 6x squared y squared. So if we multiply by 3x over 3x, we'll have the least common denominator. Okay, then we can multiply these two fractions. In the numerator, 5 times 2y is 10y. In the denominator, 3x squared y times 2y is 6x squared y squared. And we're adding that to the other rational expression. In the numerator, 7 times 3x is 21x. And in the denominator, 2xy squared times 3x is 6x squared y squared. And now that we have a common denominator, we can add the fractions. add the rational expressions. So in the numerator, 10y plus 21x. And that's as far as we go on that one. Okay, the next one, we're subtracting one rational expression from another. So we need to, before we can subtract, we have to have a least common denominator, the least common multiple of the denominators. So one denominator is 5xy, the other one is 2x. So the least common denominator has to have a factor of 5 times 2, or 10. Each of the denominators has one factor of x, so the least common denominator has one factor of x. And this denominator has one factor of y, so the least common denominator has to have one factor of y. Okay, so now we'll multiply each of those fractions by 1. Okay, when I multiply 4u over 5xy, I want to multiply it by something, so that I want to multiply by 1, but I want the denominator to end up being 10xy. So what form should 1 take on this one?
Just 2, right?
2 over 2?
Yeah.
Yeah, 2 over 2. 2 divided by 2 is 1. We're just multiplying by 1. Anytime you multiply something by 1, you're not changing its value, but we are changing its form. Okay, and then you can always check 5xy times 2 is 10xy. Okay, for the other one, we're going to multiply 3v over 2x by 1. This time, the form that 1 takes is 5y over 5y. Okay, in the next step, simplify these multiplications. This one, 4u times 2 is 8u. In the denominator, 5xy times 2 is 10xy. And then we're subtracting this one, the numerator, 3v times 5y is 15vy. And the denominator, 2x times 5y is 10xy. Now that the denominators are the same, we can subtract. In the numerator, we just get 8u minus 15vy. And the common denominator, 10xy in the denominator. Okay, the next level. Okay, this time we have 2 over x minus 2 plus 3 over x plus 5. We cannot add them until we have a common denominator. So the two denominators are just binomials. So the least common denominator is the product of the two binomials, x minus 2 times x plus 5. Okay, so 2 over x minus 2, we're going to multiply that by 1. The other fraction, 3 over x plus 5, we're going to multiply that by 1. But in each case, we're going to end up with a common denominator of x minus 2 times x plus 5. So for this first product on the left, we multiply by 1 in the form x plus 5 over x plus 5. For the other product, we multiply by 1 in the form x minus 2 over x minus 2. And now we have a common denominator. So we'll just leave the denominator in factored form, x minus 2 times x plus 5. And in this numerator, we have 2 times the binomial x plus 5, which is 2x plus 10. And then we're adding that to the other rational expression with the same denominator, x plus 5 times x minus 2. And this time we multiply 3 times the binomial x minus 2 to get 3x minus 6. Okay, now we can add the fractions. I'll go ahead and multiply the 2 binomials in the common denominator. So when you multiply x minus 2 times x plus 5, you get x squared plus 3x minus 10. And in the numerator, we have 2x plus 3x for a total of 5x. And then we have 10 plus negative 6, or 10 minus 6, which is positive 4. Okay, so this is the result we get by adding. Hey, the next example, once again, we have denominators that are binomials. So the least common denominator is just the product of the 2 binomials. So y plus 7 times y minus 3. Okay, as we've been doing, we're going to multiply each of those by 1 in a particular form. So first, 5 over y plus 7. What form does 1 take when we multiply that by 1?
Y minus 3 over y minus 3.
Yeah, y minus 3 over y minus 3. And then for the other one, 4 over y minus 3, we're going to multiply by 1 in the form y plus 7 over y plus 7. Hey, so we always have to be careful with the arithmetic. And it seems that we have to be even more careful whenever subtraction and negative numbers are involved. So in the next step, we're going to, in this fraction, in the numerator, we're going to multiply 5 times the binomial y minus 3. So we get 5y minus 15. And then the denominator, y plus 7 times y minus 3. I'll go ahead and multiply those, and we get y to the second plus 4y minus 21. When we multiply, we don't really need the parentheses around the trinomial. Okay, then we're going to subtract this rational expression with the common denominator, y to the second plus 4y minus 21. So this numerator is 4 times the binomial y plus 7, or 4y plus 28. Okay, so the next step, we have to make sure we're careful. Notice that we're subtracting the entire rational expression. But since we have a common denominator, the result of that subtraction will just be a a single rational expression with the common denominator y squared plus 4y minus 21. Okay, so we're going to combine like terms. Notice that we have 5y minus 4y. 5y minus 4y is y. And then for the constants, or the terms without variables, so we're thinking of this as negative 15 minus 28. So negative 15 minus 28 is negative 43, so we write minus 43. So this is one of those areas that sometimes students have problems with. So you have to make sure that you subtract each of the terms in that numerator. Okay, let's move on to the next page. And now we have something even more complicated, but we're going to use the same idea. So 2x over x squared plus 2x minus 8 plus 4 over x squared plus 3x minus 10. Now, we can't add these until we have a common denominator. So we need to know the factors of the denominators. So the denominator x squared plus 2x minus 8. This factors pretty nicely. The two factors are x plus 4 and x minus 2. The other denominator, x squared plus 3x minus 10, that also factors pretty nicely. The two factors are x plus 5 and x minus 2. So with the two denominators in factored form, we can identify the least common multiple of the denominators, or the least common denominator. The numerator has a factor of x plus 4, so the denominator, the least common denominator, has to have a factor of x plus 4. Both denominators have one factor of x minus 2. So the least common denominator has one factor of x minus 2. The second denominator has one factor of x plus 5. So the least common denominator has one factor of x plus 5. Okay, so the product of those three binomials is the least common denominator. So we won't bother to multiply them out. We'll just leave the least common denominator in factored form. Okay, but in the next step, we'll multiply each of those rational expressions by 1. So the first denominator on the left in factored form is x plus 4 times x minus 2. We're going to multiply that by 1 in a minute. And the other one plus 4 over x plus 5 times x minus 2. We're going to multiply this by 1. Okay, so starting on the left, we're starting with a denominator that's x plus 4 times x minus 2. The least common denominator has an additional factor of x plus 5. So the form that one takes on this one is x plus 5 over x plus 5. Then for the other rational expression, we're starting out with the denominator x plus 5 times x minus 2. So we're going to multiply by 1. Well, what factor is missing? X plus 4 is missing, so the form that 1 takes this time is x plus 4 over x plus 4. Now the two rational expressions have a common denominator. So now we can proceed. I'll just leave the common denominator in factored form, x plus 4 times x minus 2 times x plus 5. So we'll do this one in a couple of steps. In this fraction on the left, we have to multiply 2x times the binomial x plus 5. And when we multiply that, we get 2x to the second plus 10x. And then we're going to add 4 times the binomial x plus 4. So plus 4 times x plus 4 times 4, which is 16. And we can simplify a little further because the plus 10x plus 4x adds up to plus 14x. So our final result, x plus 4 times x minus 2 times x plus 5. And the numerator is 2x squared plus 14x plus 16. Okay, one thing to watch out for, so far we haven't encountered it, but it's possible to add fractions and then having to simplify the end results into lower terms. So far we haven't had to do that, and in this case, none of the factors of the numerator are the same as the factors in the denominator. But just keep in mind that you should check. Okay, the next one, now we're going to, this one involves subtraction. 3 over y squared minus 3y minus 4 minus 2 over y squared minus 5y plus 4. Before we can subtract, we have to have a common denominator. The denominator on the left, y squared minus 3y minus 4. This factors nicely. One factor is y minus 4. The other one is y plus 1. The other denominator, y squared minus 5y plus 4. The two factors here are y minus 4 and y minus 1. Okay, so the least common denominator each of the two denominators has one factor of y minus 4, so the least common denominator has one factor of y minus 4. The first denominator has one factor of y plus 1, so the least common denominator has to have one factor of y plus 1. And then the second denominator has one factor of y minus 1, so the least common denominator has one factor of y minus 1. Okay, in the next step, we'll write the factorizations of the denominators. So the first one, 3 over y squared minus 3y minus 4, is equivalent to 3 over y minus 4 times y plus 1. We're going to, in a minute, we're going to multiply this by 1. And then we're subtracting the other rational expression, 2 over y minus 4 times y minus 1. We're going to multiply this by 1. Okay, so somebody online, for this first product, what form should 1 take? We want to multiply 3 over y minus 4 times y plus 1. So the form that 1 takes is y minus 1 over y minus 1. So multiply both the numerator by y minus 1 and the denominator by y minus 1. Okay, then for the other product, so this time the form that 1 takes is y plus 1 over y plus 1. Okay, we'll proceed to the next step. We'll do this in a couple more steps. So this numerator, when we multiply 3 times y minus 1, we get 3y minus 3 over the common denominator. Then we're going to subtract this fraction. So this one is minus 2 times y plus 1. Whoops, why don't I'll just write 2y plus 2. Okay, so with the common denominator, I'll squeeze that in here. So the denominator, y minus 4 times y minus 1 times y plus 1. So what's the numerator going to be?
Y minus 1. Oh, no. I lied.
Yeah, I sort of made it messy. This is 2y plus 2. So we have 3y minus 3 over the common denominator minus 2y plus 2 over the common denominator. So when we're finished, we're going to get, well, let's do it one step at a time. So 3y minus 2y is y. And negative 3 minus 2 is negative 5. So the numerator is y minus 5. So I did get one correct answer on YouTube for the numerator. All right, the next one, y over y minus 2 plus 7 over 2 minus y. So here we'll just note that y minus 2 is equal to the negative of 2 minus y. So what are we going to do? Another way to think of this is in reverse, 2 minus y is equal to the negative of y minus 2. Do you see how that works? Okay, so I'm going to leave the rational expression on the left the way it is, y over y minus 2. And then I'm going to replace this denominator, 2 minus y, with the negative of y minus 2. So if I have a positive number divided by negative 1, that's equivalent to negative 7 divided by positive 1. So I can move the negative to the numerator and take the negative out of the denominator. And now we have a common denominator of y minus 2. So in the numerator, y plus negative 7 is the same as y minus 7. Hey, there's a question. Do we have to factor the answer if the denominator is y minus 4 times y minus 1 times y plus 1? Well, there's nothing left to factor. The numerator is as simplified as it can be, and we left the denominator in factored form, so there's nothing to factor. Okay, let's move on to the next example. Okay, the next one, 3x over 2x minus 3 minus 2x plus 1 over 3 minus 2x. This is the same sort of thing that we saw in the previous example. So we just note that 3 minus 2x is equal to the negative of 2x minus 3. So I'll leave the rational expression on the left the way it is for the moment, 3x over 2x minus 3, and then minus 2x plus 1 over, this time I'm going to replace 3 minus 2x with the negative of 2x minus 3. Okay, well, this numerator, 2x plus 1, if we think of that as a single binomial factor, if we have a positive number divided by a negative number, we can write it as a negative number divided by a positive number. So this, I'll rewrite this as 3x over 2x minus 3, and then minus the negative of 2x plus 1 over 2x minus 3. Okay, so when we subtract a negative, that's equivalent to adding a positive. So this will simplify to 3x over 2x minus 3 plus 2x plus 1 over 2x minus 3. Okay, with the common denominator, we have 2x minus 3 for the denominator, and then 3x plus 2x is 5x, and then plus 1. All right, the next one. 3x over x squared plus x minus 12 plus x over x squared minus 2x minus 3. Okay, so let's factor each of the two denominators so that we can find a common denominator. So x squared plus x minus 12. The two factors are x plus 4 and x minus 3. The other denominator, x squared minus 2x minus 3. The two factors are x minus 3 and x plus 1. And so the least common denominator is x plus 4 times x minus 3 times x plus 1. Okay, so we have to multiply each of the rational expressions by 1 in a particular form. We'll multiply this by 1. And we multiply the other one by 1 also. So in this first product, this denominator is missing x plus 1, so we multiply by 1 in the form x plus 1 over x plus 1. For the other product, the denominator x minus 3 times x plus 1, this time we're missing x plus 4, so we multiply by 1 in the form x plus 4 over x plus 4. Okay, so with the common denominator, x plus 4 times x minus 3 times x plus 1, multiply these two numerators, 3x times x plus 1 is 3x to the second plus 3x. And then we're adding x times the quantity x plus 4, which is plus x squared plus 4x. And the numerator can be simplified further. So the denominator x plus 4 times x minus 3 times x plus 1. And in the numerator, we get 4x to the second plus 7x. Okay, so in answer to the second question on a test, no, you don't need to factor the numerator. The numerator is x times 4x plus 7. Since none of the factors in the numerator are the same as the factors in the denominator, then you don't have to take it any further than this. Okay, the next one, 5x over 2x squared minus 3x minus 2 minus 4 over 2x squared minus 7x minus 4. Okay, so we want to find the least common denominator. So 2x squared minus 3x minus 2. This is going to factor. So let's see, I need plus 1 and minus 2. Yeah, that works for the factorization of the denominator on the left. The other denominator, 2x squared minus 7x minus 4. So this one I need 2x plus 1 and x minus 4. Okay, so the least common denominator, well, they both have one factor of 2x plus 1. So the least common denominator has one factor of 2x plus 1. And then the other factor is x minus 2 and x minus 4. Okay, so we're going to multiply 5x over 2x plus 1 times x minus 2. We're going to multiply this by 1 in the form x minus 4 over x minus 4. And then subtract the other one. We have 4 over 2x plus 1 times x minus 4. This time we're going to multiply by 1 in the form x minus 2 over x minus 2. Okay, so space is getting a little tight. In the numerator, 5x times x minus 4 is 5x to the second minus 20x. And then we have to subtract 4 times the quantity x minus 2. So we have to subtract 4x, so minus 4x. But we also have to subtract negative 8, which is the same as adding 8 over the common denominator. And we can combine like terms, so the numerator becomes 5x squared minus 24x plus 8 over the common denominator. Okay, the last 5 minutes of class, we'll start with section 7.4. We're going to continue section 7.4 on Monday, but we'll get started right now. Okay, so this first statement is my opinion. You can have a different opinion if you want. But in my opinion, solving equations without fractions is easier than solving equations with fractions. So to illustrate that, we have 2 equations to solve. To solve this fraction or this equation without fractions can be done in 2 steps. So 2x minus 3 equals x plus 4. First, we can subtract x from both sides, and we get x minus 3 equals 4. And then add 3 to both sides, we get x equals 7. And it's easy to check. If x is 7, then 2 times 7 is 14. 14 minus 3 is 11. And on the right-hand side, 7 plus 4 is 11. So everything checks out. Okay, here's another equation. This one involves fractions. So it's not that hard to solve, but it takes a little bit more effort. First, we have to add 5/4 to both sides. Well, it's not the only first step, but we can begin by adding 5/4 to both sides. So we get 5/12 x equals 5/3 plus 5/4. But before we can add these two fractions, we have to have a common denominator. So the least common denominator is 12. So if we multiply 5/3 by 1 in the form 4/4, and then the other fraction plus 5/4, multiply that by 1 in the form 3/3, then we get 5/12 x equals 20/12 plus 15/12 equals 35/12. Okay, then one more step. If 5/12 times x equals 35/12, we can multiply both sides by the reciprocal of 5/12. So in other words, multiply both sides by 12/5. And then 12/5 times 5/12 is 1. 1 times x is x. On the other side, the 12/5 times 35/12, the 12s cancel each other out, and 35 goes into 5 7 times. Okay, the equation on the left took considerably less time. And so we're going to discuss how to make equations with fractions or rational expressions easier to solve by clearing the denominators or getting rid of the fractions. So let's read through this, and then on Monday we'll start doing the examples. So solving equations with fractions or rational expressions. First, find the least common multiple of the denominators, which is also known as the least common denominator. You always have to be aware of restricted values, so identify the restricted values if there are any. Then multiply every term on both sides of the equation by the least common denominator. And then solve the resulting equation and check the results. So if the solutions from step 4 are not restricted values, then they are the solutions to the original equation. Okay, we're out of time for today, so go ahead and sign in for attendance.
Have a good weekend.
Dude.